Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Shazana binti Maosing, and I will explain about buoyancy and Archimedes principle, the type of buoyancy, and the difference between buoyancy and Archimedes principle. Firstly, what is buoyancy? Okay, buoyancy is a force exerted by a liquid or gas that opposes an object weight. Buoyancy also can be stated as a weight of displaced fluid. Pressure in a fluid increases with depth as a result of the weight of the overflying fluids. Thus, an object submerged in a fluid will experience a greater pressure at the bottom of the fluid than at the top. The magnitude of that force is proportional to the difference in pressure between the top and the bottom of the column, and is also equivalent to the weight of fluids that would otherwise occupy the columns, in other words, the displaced fluid. Therefore, an object that has greater density than the fluids will sink. Buoyancy applies to many settings, from vessels surveying the ocean floor to weather balloons collecting data into Earth's stratosphere. There are three types of buoyancy, which is positive buoyancy, negative buoyancy, and neutral buoyancy. For positive buoyancy, it occurs when an object is lighter than the fluids it displaces. The object will float because the buoyant force is greater than the object weight. In the sea, the salt water is less dense than fresh water and provides more buoyant force. We have to know that buoyancy and net force are not the same. Buoyancy is determined from the object volumes and density. For negative buoyancy, it occurs when an object is denser than the fluid it displaces. The object will sink because its weight is greater than the buoyant force. For example, a submarine is designed to operate underwater by storing and releasing water through ballast tank. If the command is given to descend, the tank will take in water and increase the vessel density. For neutral buoyancy, it occurs when an object weight is equal to the fluids it displaces. For example, a scuba diver is trained in technique to regulate buoyancy underwater. Swimming horizontally and taking deep long breaths allow the divers to propel forwards, not upward. Other than that, fish control buoyancy through an internal swim bladder. Similar to a submarine, the bladder is filled with gas as a means of altering buoyancy. Next, we move to Archimedes principle. Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. The value of thrust force is given by Archimedes' law, which was discovered by Archimedes of Syracuse of Greece. When an object is partially or fully immersed in a liquid, the apparent loss of weight is equal to the weight of liquid displaced by it. In equation form, Archimedes' principle can be written as in the box beside. From image A, an object submerged in a fluid experiences a buoyant force, or Fb. If Fb is greater than the weight of the object, it will rise, while if Fb less than the weight of the object will sink. From image B, we can see that the object was removed. When the object is removed, it will be replaced by fluids having weight, or omega. Since this weight is supported by surrounding fluid, the buoyant force must equal the weight of fluids displaced. How is buoyancy is different from Archimedes' principle? The difference between them is buoyancy is describing about the force of fluids that exert on an object is different or lesser density than itself, while Archimedes' principle is describing about one aspect of buoyancy, that the buoyancy force exerted on an object under fluids is equal to the weight of the fluids it displaced.
Assalamualaikum and hi everyone. My name is Nur Hafiza binti Abdul Wahid. So today we are going to be talking about relationship between Archimedes' principle and buoyancy. Buoyancy is a force exerted by a liquid or gas that opposes an object weight. Buoyancy can also be stated as the weights of displaced fluid. Pressure in fluid increases with the depth as a result of the weights of the overlying. Thus, an object submerged in a fluid experiences a greater pressure at the bottom of the fluid than at the top. This difference in pressure results in a net force that tends to accelerate an object upwards. The magnitude of the force is proportional to the difference in pressure between the top and the bottom of the column, and is also equivalent to the weights of the fluid that would otherwise occupy the column, like displaced fluid. It is for the reason that an object whose density is greater than that of the fluid that is submerged in will sink. Archimedes' principle allows for the experimental determination of density by providing an easy and also accurate method to determining the volume of an irregularly shaped object. Archimedes' principle and allows the buoyancy of an object partially or wholly immersed in a liquid to be calculated. The downward force on the object is simply its weight. The upward or buoyant force on the object is that stated by Archimedes' principle. Thus, net upward force on the object is a difference between the buoyant force and its weight. If this net force is a positive, the object floats. But if a negative or zero, that is neutral buoyancy. That is remain in place without either rising or sinking. Archimedes' principle states that where a body is partially or completely immersed in a fluid, it experiences apparent loss in a weight which is equal to the weight of the fluid displaced by the immersed part of the body. Archimedes' principle does not consider the surface tension acting on the body, but the additional force modifies only the amount of fluid displaced. So the principle that buoyancy equal to weight of the displaced fluid remain valid.
Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Today I would like to talk about the formula and example of buoyancy and Archimedes principle. Okay, first we're going through the formula. So first, the formula for the force of buoyant, that is equal to pressure of fluids times to gravity times to the differences of height of immersed part and times to area. Another one of force of buoyant is equal to pressure of fluid times to gravity times to volume of fluid equals to mass of fluid times to gravity. Another one is for the density. So as you can see there, we can relate to force of buoyant equal to wave of fluid equals to mass of fluid times to gravity and equals to pressure of fluid times to volume of fluid times to gravity. So the conclusion that we get is force of buoyant is equal to pressure of fluid over the pressure of object times to wave of object. So for the previous slide, you can see we have the longest formula for buoyant force, and another one is the much shorter of buoyant force. So this is step for from the longest to the short buoyant force formula. So first, as you can see there, to take the formula that involves the pressure fluid times to gravity times to differences of height of immersed part times to area, and then they substitute the immersed part times to area with the volume of fluid, and then as you know too, the buoyant force is equal to mass of fluid times to gravity. So the final of derived is the force of buoyant is equal to pressure of fluid times to gravity times to the volume of fluid that is equal to mass of fluid times to gravity. Also, we can say the wave of fluid. Okay, then we move on to the example of Archimedes principle and buoyant force. So the question is, what is the buoyant force in air on the spherical helium balloons with a radius of 30 cm if the pressure of air is 1.29 kg per meter cube? So the condition is neglect the wave of the balloon material. As you can see and understand, the buoyant force of the balloon is equal to wave of volume of balloon. So before we find the force, we must find the volume of balloon first. So the solution is we must list of all of the information that we get from the question, such as the radius and the pressure of air, and then we use the formula of volume of spherical for balloon, and we got 0.11 meter cube. After that, we use the force of buoyant, which is pressure of air times to volume of balloon times to gravity, and we get 1.4 Newton. That's it.
Assalamualaikum to the doctor. My name is Nohazimah binti Cik Muhammad Arifin. I will talking about the application buoyancy and Archimedes principle in daily life. For the application buoyancy principle in daily life, there are three applications which are submarine, hot air balloon, and hydrometer. For the submarine, a submarine has a large ballast tank which is used to control its position and depth from the surface of the sea. A submarine submerges by letting water into the ballast tank so that its waves become greater than the buoyant force. Conversely, it floats by reducing water in the ballast tank. Thus, its weight is less than the buoyant force. Next, for the hot air balloon, the atmosphere is filled with air that exerts buoyant force on any object. A hot air balloon rises and floats due to the buoyant force. When the surrounding air is greater than its weight, it descends when the balloon weight is higher than the buoyant force. It becomes stationary when the weight is equal to the buoyant force. The weight of the hot air balloon can be controlled by varying the quantity of hot air in the balloon. And for the hydrometer, a hydrometer is an instrument to measure the relative density of liquid. It consists of a tube with a bulb at the end. Lead shorts are placed in the bulb to weight it down and enable the hydrometer to float vertically in the liquid. In a liquid of lesser density, a greater volume of liquid must be displaced for the buoyant force to equal to the weight of the hydrometer, so it sinks lower. Hydrometer floats higher in a liquid of higher density. Then, for the application Archimedes in daily life, there are three applications which are lactometer, ship, and fish. For the lactometer, based on Archimedes principle, are used to measure purity of a sample milk or test the richness of the milk. It measures the relative density of the sample milk is respect to the water. If the specific gravity of a sample milk is within the approved range, the milk is pure. If it's not, then there is some adoration. Adoration is the action of making something poorer in quality by the addition of another substances. Next, for the ship is a ship floats on the surface of the sea because the volume of water displaced by the ship is enough to have a weight equal to the weight of the ship. A ship is constructed in a way so that the shape is hollow, to make the overall density of the ship lesser than the sea water. Therefore, the buoyant force acting on the ship is large enough to support its weight. Density of sea water varies with location. The plumb shoal line marked on the body of the ship as a guideline to ensure that the ship is loaded within the safety limits. A ship submerged lower in fresh water as freshwater density is lesser than sea water. Ship will float higher in cool water as cool water has a relatively higher density than a warm water. For the fish, the certain group of fishes use Archimedes' principle to go up and down the water. To go up to the surface, the fishes will fix its swim bladder exact with gases. The gases diffuse from its own body to the bladder, and thus making its body lighter. This enables the fishes to go up. To go down, the fishes will empty their bladder. This increases its density and therefore the fish will sink. That's all from our group. Thank you.